Welcome back. Today we're doing a really high-speed deep dive. We're going to be dissecting the specs for a piece of high-performance data infrastructure, our source material, the PureLink FLC2-070 fiber optic cable. And when you see the price, it's about $439.99 for a 70-meter cable. You have to ask the question, what exactly are you paying for here?
That's the core of it, really. You're investing in immunity.
Immunity.
Yeah, immunity from electrical interference. That's the huge advantage of fiber optics. It gives you incredible speed over long distances. And this specific cable, it's designed to work with high-end pure media and HD tool systems.
So environments where you just can't have signal failure.
Exactly, like places where data fidelity is, non-negotiable.
Okay, so if the speed is just an inherent part of fiber optics, then the premium price must be for the reliability, the physical construction.
It is. Let's start with the endpoints, the connectors. That's where precision is everything.
What are we looking at here?
This is a pre-terminated 50125 multi-mode fiber. That number, the 50125, just refers to the diameter of the glass core and its cladding. It's the standard for this kind of work.
And it uses those standard LC connectors I see everywhere.
It does, but with a critical difference. It's housed in an RJ-style push-pull mechanism.
That sounds like a small convenience feature. Is that really part of the cost justification?
It's absolutely essential engineering. Think about a crowded server rack.
Right. No room to move.
Exactly. That little housing lets you unplug it easily without tools, without stressing the cable next to it. It prevents outages, so you're paying for deployment reliability.
Okay. That makes sense. And what about standards? I see it's RoHS and TAA compliant.
Right. RoHS means it restricts hazardous materials, and TAA means it meets very strict requirements for, say, government contracts. It's a guarantee of responsible manufacturing.
So it's built responsibly.
Yeah.
But how do they prove it will actually perform? How do you guarantee the signal gets through all 70 meters?
That comes down to testing. Every single cable is tested to guarantee minimum insertion loss.
Insertion loss.
It's just the engineering term for how much signal strength is lost right at the connection point. The lower that number, the cleaner your signal.
Okay, so this is where it gets really interesting for me. Inside the cable, the specs mention aramid yarn. That's the material from body armor, right?
That's the one. And this is where the material science really starts to justify the cost.
So how does it work?
Well, the protection starts with something called the tight buffer. It's made of a material called Hytrel.
Hytrel.
It's a high-performance thermoplastic. It's chosen because it's flexible, but also incredibly resistant to stress. Its job is to hold the microscopic glass fiber in the exact same position.
If it moves even a little?
You get light refraction, signal loss, game over. Then, wrapped around that, you have the aramid yarn.
So that's the armor.
Think of it more like the cable skeleton. It provides tensile strength. It means you can pull this thing through a conduit without stretching or snapping the delicate glass inside.
And the final layers, the sheathing. That tells you where the cable is designed to live.
Correct. And here you have a choice. The inner and outer sheaths can be PVC or something called LSZH.
Low smoke, zero halogen.
Exactly. And that choice is critical. In a fire, normal PVC releases thick, toxic, corrosive smoke. LSZH doesn't. It drastically reduces that toxic smoke, which can buy crucial time.
I also noticed the weight. It's listed at 21 kilograms per kilometer. That's almost 47 pounds. It speaks to how much physical material is actually in here, all just to protect those tiny strands of glass.
And that really connects to the big picture, doesn't it? This deep dive shows that maximizing data speed isn't just about the glass. It's about millimeters of specific polymer and yarn engineering.
Hytrel and aramid.
All working together to maintain a perfect signal under stress over that full 70-meter run.
So when you look at it that way, you're not just buying a cable. You're investing in a piece of applied material science, all designed for zero compromise. Now, here's a thought for you to take away. We talked about data centers. But what specific high-stakes public environment, maybe a major transit hub or a crowded arena, might absolutely require that LSZH material over standard PVC for reasons that go beyond just the toxicity concerns we mentioned?